Today, we're addressing a significant issue in the depths of space: space debris. Space debris consists of fragments of waste that orbit our planet uncontrollably, posing a serious threat to both current and future space missions. Let's delve into this topic in more detail and examine it scientifically. Space debris refers to artificial objects and particles that have accumulated in Earth's orbit due to human activities and are no longer functional. These objects range from rocket parts that separated during launch to decommissioned satellites to small metal fragments resulting from collisions. As of 2023, it is estimated that there are approximately 34,000 pieces larger than 10 centimeter and 128 million pieces smaller than 1 millimeter in orbit. Space debris originates from various sources, including satellite collisions and fragmentations, rocket stages and separation parts, and defunct satellites and spacecraft components. For example, the 2009 collision between the Iridium-33 and Cosmos 2251 satellites created about 2,000 large pieces and hundreds of thousands of smaller fragments. Additionally, parts that separate during different stages of rocket launches are common sources of space debris, especially in low Earth orbit, LEO. Moreover, satellites and spacecraft that have completed their missions or malfunctioned also drift aimlessly in orbit. Space debris poses a serious threat not only to spacecraft and satellites, but also to astronauts. In 1986, during the re-entry of the Soviet satellite Cosmos 1402, which had a nuclear reactor, the third stage burned up in the atmosphere, and some parts fell to Earth. This incident demonstrates that space debris can pose dangers not only in space, but also on Earth. Furthermore, the high speeds at which space debris travels mean collisions can cause significant damage. Structures like the International Space Station, ISS, must regularly change their orbits to avoid such collisions. Various strategies have been developed to address this problem. Active debris removal systems aim to capture and safely dispose of space debris. For instance, nets and harpoon systems can catch large pieces and bring them back to Earth. Satellite operators also plan to move their satellites to a graveyard orbit, a distant orbit, at the end of their operational lives. However, these solutions face technical and financial challenges. In the future, stricter international regulations and collaborations will be necessary to reduce space debris. These solutions are crucial for maintaining a sustainable space environment. The severity of the space debris issue is of great importance for the future of space exploration and commercial activities. Technological advancements and international cooperation will play key roles in resolving this problem. Space agencies and private companies continue to develop innovative solutions to combat space debris. In conclusion, space debris is a significant issue that hinders humanity's progress and exploration in space. Solving this problem requires not only scientific and technological advancements, but also international cooperation and regulations. Ensuring a sustainable future in space involves responsibilities for all of us. Therefore, raising awareness and taking necessary steps to combat space debris is a shared mission for all humanity. Each new rocket launch and the deployment of new technologies into orbit contribute to the rapid growth of the space debris problem. Space debris isn't just about accumulating waste in orbit. It also brings with it a significant pollution issue that extends beyond Earth's atmosphere. In this context, the pollution generated by rockets burning fuel on their way to space is also an important consideration. Firstly, one of the main reasons for the rapid increase in space debris is the growing dependence of modern society on space. Constant launches of new satellites are required for applications such as communication satellites, weather forecasts, GPS services, and many others. Each launch brings along a series of parts that can remain dormant in orbit after completing their function. As of 2023, it's estimated that there are over 34,000 pieces larger than 10 centimeters and 128 million pieces smaller than 1 millimeter in orbit. These pieces pose a serious threat to other satellites and spacecraft due to their high velocities. Collisions can lead to a chain reaction known as the Kessler syndrome, where debris in orbit increases uncontrollably. Another important point is the pollutants released into the atmosphere by rockets. Chemicals emitted into the atmosphere as a result of rocket fuel combustion harm the environment and contribute to climate change. Solid-fueled rockets produce toxic compounds like perchlorates during the combustion process, while liquid-fueled rockets emit gases such as carbon dioxide, water vapor, carbon monoxide, and various nitrogen oxides. These gases can cause lasting changes in the atmosphere and damage the ozone layer in the stratosphere. Particularly with the increase in space tourism and commercial space flights, this pollution issue becomes even more significant. Addressing the problems of space debris and rocket pollution requires international collaboration and innovative technological solutions. Active debris removal systems aim to capture and safely dispose of large debris in orbit. For example, the European Space Agency's ESA ED-Orbit mission aims to capture large space debris and ensure controlled burning in the atmosphere. Additionally, the graveyard orbit strategy implemented by satellite operators involves moving decommissioned satellites away from operational orbits. Such measures can help reduce the amount of debris in orbit. Various solutions are also being developed to reduce the environmental impact of rocket fuels. For instance, SpaceX's reusable rockets aim to minimize material waste and environmental impact by reducing the need for new rockets with each launch. Furthermore, research into green rocket fuels aims to develop less toxic and more environmentally friendly alternatives. Such fuels can reduce harmful emissions during launch and contribute to the fight against the space debris problem. In conclusion, with each new rocket launch and the deployment of new technologies into orbit, the problems of space debris and pollution are rapidly growing. International collaboration, innovative technologies, and environmental awareness are crucial for ensuring a sustainable future in space. Addressing these issues of space debris and rocket pollution is not only critical from a scientific and technological standpoint, but also from an environmental and social responsibility perspective. Space debris is a pollution problem consisting of discarded and uncontrolled fragments orbiting Earth. These debris encompass a wide range of items, from rocket parts used in launch stages to defunct satellites, various spacecraft, and particles resulting from collisions. A review published in the International Student Project Reporting Journal indicates that this issue of space debris is reaching a critical level at an increasing rate and requires urgent solutions. Several reasons contribute to the growth of this problem. Firstly, the rapid growth and development of the space industry have increased the quantity of space debris. Increased satellite launches, space stations, and other spacecraft have led to more debris accumulating in orbit. Additionally, increased space activities raise the potential risk of collisions. Secondly, the existing issue of space debris has become more complex with the involvement of many different countries and private companies in space activities. With each country having its own space agency, or private space industry, coordination of activities in space and tracking of debris become more challenging. The lack of international cooperation is a significant barrier to effectively monitoring and cleaning up space debris. Thirdly, the problem of space debris poses a serious threat due to the debris being able to remain in orbit for extended periods and posing a risk of collision with other spacecraft. Collisions lead to the formation of new debris and the fragmentation of existing debris into smaller pieces, creating a domino effect known as the Kessler syndrome. In this scenario, the number and velocity of debris orbiting could increase to the extent that safe travel in space becomes impossible. In conclusion, the issue of space debris poses a serious threat to the future of space exploration and commercial space activities. Addressing this problem, which requires international cooperation and urgent solutions, is not only critical for the space industry, but also essential for reducing the environmental impacts of our planet in space. Jennifer Stein, David Castillo, Elise Bedell, Ariana Thomas, and Nicholas Valiente, experts from the University of Florida, delved into a comprehensive study on the issue of space debris, focusing on exploring solutions. This research aimed to identify the most environmentally friendly and cost-effective methods for cleaning up space debris. Stein and her team assessed various approaches for space debris cleanup. These included active debris removal operations, enhancements in satellite design, strategies for deorbiting debris, and recycling. By considering the effectiveness and environmental impacts of these methods, the researchers endeavored to pinpoint the most suitable approach for addressing the space debris problem. The findings of the study revealed that an integrated approach proves to be the most effective path for space debris cleanup. This approach encompasses monitoring existing debris, thwarting future debris formation, and executing active debris removal operations. Moreover, environmentally friendly practices such as advancements in satellite design and recycling play pivotal roles. The work conducted by Stein and her team underscores the feasibility of a scientific and technological solution to the space debris issue. This study contributes to the objective of fostering a safer and more sustainable space environment for future generations by mitigating environmental pollution in space. Space debris indeed poses a significant threat. Large debris carry the risk of colliding with other spacecraft in orbit, while even small particles can cause substantial damage. Particularly, space debris traveling at high speeds can inflict severe damage or render other vehicles completely inoperable upon collision. For instance, a piece just a few centimeters in size colliding with a satellite during launch can cause substantial damage to both the satellite and its equipment. Space debris also poses a significant risk to astronauts. Manned vehicles like space stations are vulnerable to collisions in orbit, which can have serious consequences. If a debris fragment enters orbit or a collision occurs, astronauts' lives could be at serious risk. Therefore, the threat of space debris must be taken into account when planning and conducting space missions. Moreover, there is also a risk of space debris falling to Earth. Large fragments entering the atmosphere uncontrollably can land in populated areas and cause significant damage. For example, while Russia's Mir space station re-entered the atmosphere in a controlled manner in 2001, some parts fell to the south of Tahiti and the Pacific Ocean. Fortunately, no harm came to individuals in this event, but the risk could be greater in similar future occurrences. The international community recognizes the seriousness of the space debris problem and is working to find solutions. However, more collaboration and innovative approaches are needed to address this issue. Space agencies, private companies, and international organizations must come together to develop new technologies for space debris cleanup and formulate effective policies. In this way, we can tackle the problem of space debris and provide a safer space environment for future generations. Sure enough, that's a fact. Collisions between space vehicles, they sure can worsen the space junk issue and practically create a debris cloud up yonder in orbit. From them collisions, you get thousands of tiny bits floating around, posing a real danger to other vehicles and space stations up there. These here collisions between space vehicles, they usually happen because of reckless maneuvers or errors in predicting the paths of satellites and debris pieces carrying collision risks. And when these collisions occur, them pieces moving at high speeds can cause major damage to other vehicles and even spawn fresh debris. This situation, it just makes the space junk issue more tangled up and makes finding a solution even harder. 'Cause you got more and more pieces up there in orbit, and each one spells out a risk of collision for other vehicles. That makes it mighty risky to travel and conduct space exploration. To solve this here space junk problem, we need not only international cooperation and innovative technologies, but also more effective tracking and prediction systems. We got to set up more precise and reliable systems to keep tabs on satellites and space debris, and that can help reduce the risk of collisions and get a handle on the space junk problem. Plus, measures like active cleanup operations and more eco-friendly satellite design can pitch in toward solving the space junk problem. In conclusion, them collisions between space vehicles, they sure do make the space junk issue worse and can create a real mess up there in orbit. That's why we gotta put in more effort and take more effective measures to solve this here problem. International cooperation and coordination are crucial to making space safe and sustainable. Yes, the security standard you mentioned is indeed an important step. This 25-year security standard, which is used to reduce space debris, helps effectively dispose of uncontrolled spacecraft and debris fragments. According to this standard, placing unused objects into lower orbits allows them to gradually enter the atmosphere and burn up. This prevents space debris from orbiting uncontrollably and reduces the potential collision risk. When these objects enter the atmosphere and burn up, they no longer pose a potential threat to Earth. However, in some cases, it may not be possible for objects to enter the atmosphere, or it may lead to undesired consequences. In such cases, they are preferably moved to a designated graveyard orbit. This orbit serves as a safe storage area for inactive satellites and debris fragments, minimizing the collision risk with other spacecraft in different orbits. This helps prevent the accumulation of space debris in orbit and enables a more effective management of the space debris problem. This security standard is taken seriously and implemented by the space industry and space agencies. However, further steps and more effective measures are needed to solve the space debris problem, particularly developing more sensitive systems for tracking and predicting space debris and using more effective technologies for space debris removal are important. Continuing with such standards and measures will help reduce environmental pollution in space and ensure the safety of space exploration. Effectively addressing and controlling the space debris problem is crucial for a sustainable future in space. Space debris is becoming an increasingly serious issue. That's why scientists and engineers continue solution-oriented efforts without slowing down. Firstly, active cleaning technologies are being developed and implemented. These technologies aim to render space debris ineffective by capturing them and causing them to enter the atmosphere. However, the development and operation of such systems are quite complex and may require high costs. Secondly, work is underway on more environmentally friendly satellite designs. These designs aim to reduce the amount of space debris by ensuring that the materials and components used are recyclable. Additionally, lighter and more compact satellite designs could reduce launch and operation costs, thereby reducing the space debris problem. Thirdly, focus is placed on recycling and reusing measures. Recycling and reusing satellite and spacecraft components could help reduce waste and keep space debris levels under control. All of these efforts are seen as promising steps towards solving the space debris problem. However, more research and development work is needed to solve this problem. Therefore, scientists and engineers continue to address this issue by embracing international cooperation and adopting innovative approaches. Of course, keep following our channel to keep your interest in space and science topics alive. In our future videos, we'll provide more content about the latest discoveries in space, scientific breakthroughs, and mysteries waiting to be explored. As long as you subscribe and turn on notifications, you'll be informed about our newest videos. Until next time in the next video, goodbye.